Hello there, welcome to a new video in machine learning. Today is my 11th video and I am going to take about MAE, that is mean absolute error, mean squared error, that is MSE, and root mean square error, RMSE. And before I move on, where I'll be using this one or where we'll be using this one, let's take an example. We have already trained a data set. Every trained data is bound to have some error. And how do you calculate that error, how the different points occur, and how do you calculate that error? We are going to use these three terms, correct? Mean absolute error, mean square error, and root mean square error. So let's take a point on the graph. This is what we have got our predicted values, and these are the predicted values, and these are our actual points. So the difference between these 2 points is called an error. So we have got a predicted values which are there, but it's our actual value. This we call it as error. We have already trained a data, and that trained data, it's supposed to have some error. And how do you calculate? This is our trained data, and this is our what you call actual out points. So there should be an error. So we got a predicted points and actual points that which have already been trained. And when the trained model bound to have some error, these are some error. For an example, in this graph which I have drawn, I have just taken only 2 points. Correct? Now, if I take more than 2 points, then how will be? It's not like that we have 2 points, we can have n number of points. How do you calculate it? And how do you calculate that total? We are going to see these points. Okay. Now let's take an example. As I already told you, these are my actual points, these are my predicted points, and these are my errors. Now error is being calculated by my actual point, actual data by predicted data. My actual, let's take example. This I call it as y dash, and this is I call it as y predicted data, or this I call it as y minus y dash, y minus y dash. This is my array predicted data. Now what is mean absolute error? We have already got error. It's here E. What is A? Is nothing but your absolute. A stand for absolute. Now if I calculate 8 error, it's minus 8, I'll make it to 8. If I calculate error 6, it should be 6. If I calculate error as minus 5, it should be 5. So I take this one into absolute values. And the more important is mean. I'm just not counting about 2 points. I'm taking about overall points. So how many points are there? Let's take example. It should be sigma I is equal to 1 to n. So these are the all points. So sigma I is equal to 1 to n. And what should be the mean? By n. That is 1 by n absolute y minus n. And mean square average is nothing but error set for prediction without considering the direction. And without considering the direction, that is more important point. And the low mean indicate better model performance, and higher mean indicate there is an error. And what for this mean square, mean absolute error, mean square error, root mean square, all metrics are used to evaluate the accuracy. I just told you about accuracy about regression model. So this is our model which we have created, and we want to calculate the accuracy. So this is our mean absolute error. Now let's move on to other mean squared error. So we have already got the mean error which is available here, and mean square is our overall dimension of this one. So what is this? We have already got this one. Now let's take this modulus and make it square. Make it square. This is what S. S is nothing but square. Whereas here it was represented with A, and here it is represented by S, mean squared error. And why it is given that one? Let's take example here. Now my what do you call its dimensions. If it is a pound, after calculation it will be pound. If it is rupees, after calculating it will be rupees. If it is any Indian rupees or any dollar sign, it will be after calculating, it will be dollar sign. Whereas here, if I put square, the actual pound will become pound square, actual rupee become points rupee square. That is major disadvantage here. Units will be changed. MSB is nothing but MSC measure the average square of error. That average square difference between the estimated value. For an example, let's take an example. This is my predicted value. This is my actual value. 2. If I make it square, it will be 4. If it is 3, it will be 9. For this point, it is 100. 10 means it is 100. So we are making that error too big square between the estimate value. What is this? It gives us the higher weight for larger error. It give you the higher weight for the larger error. Do remember, it will give you the higher weight for the larger error at this point, and the dimensionalities or the units what you are going to choose will be changed. This is the major disadvantage in mean square error. Then root mean square error. MSE, we have already got it. Then we root this one. MSC, we have already got it. We square it. This means we are removing this square. RMSE root square, average square root difference between predicted and actual observation. The linear scale corresponded to this. What are the difference between that? Easy to remember because it gives you the overall interception. It penalize larger error by giving more weightage. RNC combined both the value benefit of MSC while being interrupted the same unit by original unit. It give benefits to this, it give benefits to this one by giving the same unit. Now let's take an example. I have got an actual weight 3, 5, 7, 9, and my predicted weights are 2.5, 4.8, 7.2, and 8.7. So this is my actual weight y, this is my predicted weight y dash. As I have told you here, what is this? I have already told you my actual weight and my predicted weight. I have already taken y values, y dash. The same way I have taken it. Step 1, calculate the error y minus y1. 3 minus 2.5. 3 minus 2.5, I have got 0.5. 5 minus 4.8, I have got 0.2. 7.2, I've got minus 2. This, I've got 3. Now calculate the mean. Mean is how many values? I've got 4. 1 by 4, 0.5, 0.2, 0.2. Because as its modulus, I'm going to take plus 1, plus 3. 1.2, I've got 0.3. Correct? My mean MAE is 0.3. What is this mean? If it is less, mean measure indicate a mean lower indicate my model performance better. My model performance, is it lower? Yes, it's lower. Now let's move on to mean square. MSE, I have got 1 to n sigma. This is my formula. Y minus y dash whole 0.5 whole square, 0.2 whole square, minus 0.2 whole square, minus 0.3 whole square. This is 0.24, 0.404, this all this square. So how much I got? 0.15. 0.105. RMSE, that is square root of this one. RMSE I have got is 0.0325. So this is how it is calculated. Let's see with the graph. This is my actual weight. This is my actual weight. This is my predicted weight, and what are the values I have got it. This is the one which is shown in the graph. The differences, correct? And this is what in a matrix. This is MSE, which is low. This is what we have got MAE, and this is my mean. So this is, if the error is there, it will give you more weightage to higher error. The summary of this one is this one. If it is less, we can able to tell that our product is our data set is going to get well, or our program is going to set well. And I have already taken the values, correct? So it's there's some different values. NumPy 5 I have taken some NumPy 5 for using these data sets, arrays, and plotting graph, and all this matrix. So I have got different points 3, 5, 7, 9, 11, and the errors are 2.5, 5 for this one, this, for this one, this one, this, for this, and this. Correct? Now I have calculated the mean and I have represented in the print value. Then I'm going to plot the graph with label y1 then, and in the higher value of errors, I'm going to plot which for a range from actual length, then plotting the graph. Let me go through the what you call in program, and I'll see the output. Okay. It's here. I have got number 5, the same data which is available here, which we are going to see about this one, and the same data we are going to tell, and we are going to calculate actual mean, absolute error, actual value by predicted value, and we are also going for this one. Correct? And what is the value I've got? This is the value I've got, mean RMSE, and this is my actual and product values. This is the graph which they have drawn it. Correct? I hope you have already learned it. Thank you very much for seeing this video. Please click like button and do subscribe to my channel. Thank you very much.